We learned in the previous video that conversions were cast actions. We also saw a particular case of conversion, identity conversions, which are a second cast action. We will discover a third cast action, which is a particular case of reinterpretation. It means that there is no bit transformation. The bits remain the same, but the action is both a reinterpretation and a little bit more than that. I'm referring to type qualifier casts. Type qualifiers in C are keywords like const and volatile. Since you haven't often had the opportunity to use the volatile keyword, I'll mainly focus my examples on the const keyword, which you are familiar with and are using a lot. Let's discover this example together. We have the same example structure as in the previous examples, which means that we will use a reference value, which will be the a variable of the integer type, which will be initialized to the 42 value. In this example, I'll make an address reinterpretation with my a variable. The pointed integer must be constant. Of course, the notion of type qualifier will add a notion of hierarchy through our types, meaning that we'll have accurate types and less accurate ones. Though this explanation isn't particularly suited for the const notion, the vertical relationship is still true. So we'll be able to make an implicit and explicit reinterpretation of the type qualifier of the address of an integer. It means that the address of a constant integer will be broader, higher, than the one of an integer, which will be lower, more accurate, even though, once again, the semantics aren't really suited for this example. This means that we'll be able to easily move from a mutable address of a normal variable to the address of a constant type. Here we have the implicit example and explicit one as below. In this case, everything is fine. We're moving up. But the question is, what happens if we want to move down? We saw in the previous examples that every time we want to gain accuracy, meaning moving down, it would cause problems. We would have strong results either when converting or when reinterpreting. Here, the problematic will be very slightly different. Because if you just want to go from a constant address to a non-constant one, it won't compile. The compiler will refuse to do this reinterpretation of the type qualifier. In the case of an implicit demotion, to tell the compiler explicitly that you want to turn an address of a constant type into one of a non-constant one, you'll have to use the explicit syntax of the C cast with parentheses. This line won't compile. The compiler will refuse it. Why? Simply because with this little cast trick, you'll be able to access constant variable in writing, while it's supposed to be read-only. So to protect your code, the compiler forbids this line. However, if you want to get around the semantics with the const keyword and access in writing a value supposed to be a constant, you should use this syntax. To make sure of that, let's run a little compilation. Here you can see that as expected, the compiler won't compile this line. We had D, which was the address of the constant integer, and we wanted to reinterpret it as the address of a mutable integer. And this compilation has been refused since the semantic of the const keyword would have been broken. However, you notice that the compiler isn't complaining at all about the following line on which I did this interpretation explicitly. It's very disadvised to change the type qualifier of an address. And that's often the symptom of a conception issue in your program. If you find yourself in a situation in which you need to do this reinterpretation, two possibilities: either you made a mistake, in which case you'd be better off redesigning your program to avoid doing this reinterpretation of the type qualifier, or you're in a situation in which you're using a code you don't own, for example, a library. and you're using a function of the library, and in the prototype, you have a type or a parameter that should have been const, but the developer forgot to make it constant because he codes poorly. From there, you're not responsible for the programming error in the library, but as you code properly, you have a constant value, which you'd like to use with the function of the library. In this case, you could consider reinterpreting your constant address as a non-constant one to be able to use the function with the library. Of course, we assume that the function does what it's supposed to do, meaning not modifying your parameter. Actually, that's why it should have been a constant. In this case, you should use this qualifier type reinterpretation to keep programming. However, if the code is yours and you have access to the source code, just fix it. Your code will be much better, and that's the way to do it. That's the end of our 3-video series on CCAS. I think you've learned a certain number of things, even though you're quite familiar with the notion. And now we'll be able to move on to the application of these notions in the C++ context. I'll see you very soon.